Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back everyone. Today inshallah Rabbain we'll talking about the two kinds of fraction, and we'll talk about the coefficient of fraction, and also we will answer some problems about the fraction. Let's start. At the beginning, guys, in the Newton's first law, if you remember, the Newton's first law said that if we have an object and this object at rest, now this object will be in equilibrium. Okay, it means we have we have a normal force and we have weight. All of them will make this object at rest, and this object, the net force will equal 0. Okay, that is the first law of Newton. Okay, and the second Newton's law said that if we exert in this object with force, this object should to accelerate. Right, that is the second Newton's law. But in fact, that's not happening sometimes. Do you know why? Because of the fraction. Sometimes if we have very huge object like that, okay, suppose that we have very huge object and your brother try to push this object with very small force, this object not move. Why? Because we have opposite force come from the fraction will exert in this object in opposite direction at the same of magnitude of applied force. Now we have applied force, and this applied force will be very small, and we have force come from the fraction. This force called static fraction. Static fraction. It means that is the fraction will resist the initiation of sliding of motion or opposes to a slide of motion for this object, not let the object to move. And this force is the same magnitude of applied force and the opposite direction for this applied force. Okay, if we have more force than this, now you will help your brother to push this huge object. Just a minute, guys. Now you will help your brother to push this object, but this object still not move. Why? Because of the static fraction more than the applied force. Because that this object still not move. Okay, now let's read the definition of the static fraction to understand more about the fraction. Okay, the static fraction. Okay, now I want some of please guys to read the definition of this. Abdullah Abdulazim.
Initiation of sliding motion between two surfaces that are in contact and
yeah, look over, guys, be more concentration in this point. Now static fraction resist. Now static fraction resist the initiation sliding, not need the object to move, and the contact between the surface and the object at rest, both of them at rest, the object not move yet. That is static fraction. That is static fraction, guys. Okay, now the object will move when we exert with more force to this object. Now your father come to exert in this object. Just I will erase some lines to be more clear for you. Okay, now your father come to help all of you to exert in this object. Now the applied force will be greater than the static fraction. Okay, and this object start to move. But before it start to move, you will push this object with very huge force. That is called maximum force, or called maximum static fraction. Okay, before the object move, you will make a lot of force to start to move. When the object move, you can feel that sometimes. The object will move easier than the beginning. Why? Because of that is another kind of fraction that is called kinetic fraction. kinetic fraction, it will be another kind of fraction, and it will be less than the static fraction. And we will speak about that now more. Okay? As long as the object does not move, the static fraction always equal to the applied force. If the object is still at rest, now the static fraction equal the applied force. But when the object start to move, now we have another kind of fraction that is called kinetic fraction. Before talking about kinetic fraction, let's talk about something else, about the surface. Most of you think that the surface will become smooth, okay? But in fact, that's not right. If we look over if you look over in your book, you can see that here this picture you have about the this picture. This is the microscopic level of surface. You can see that we have some things get out from the surface like that, okay, and the upper one that is the object, and the down one that is the surface. Okay, some of you think that the surface is smooth, but in fact no, the surface not smooth. Can you see that here in the microscopic level? You can see that we have some things get out from the surface and don't let the object to move. Okay, and we have something, and you can see that also the surface with the object will contact in just a little bit points. Okay, will contact with each other in little bit points. Okay, and this contact called electrostatic force, or called also adhesion. Okay, you can find that in your book here. Okay, you can find that it's written italic down here. Okay, where is that? Yes, adhesion. Yeah, adhesion, it means the contact between two surfaces that in electrostatic force, okay, will contact with each other in electrostatic force. Okay, guys? Now that is the surface. Okay, now let's give you some notes about the fraction. Again, the fraction will be every time the opposite of the applied force, and it will be parallel to the surface, that is the fraction, and the static fraction will become the same magnitude of applied force. But on the other hand, the kinetic fraction will be different. Okay, what about the kinetic fraction? Now, kinetic fraction will happen when the object moves. Now the object move, and still we have fraction exert in this object, but the object will move, and the kinetic fraction will be less than the static fraction. You can realize that when you push the bus or when you push car. You can realize that you will make a lot of force at the beginning to let this car to move. But when the car move, it will be easier, very easy to push the car now. Okay, and when you drive the car also, okay, at the beginning the car will take a lot of time to start to move. When the car move, that's very easy to move in 100 km per hour or 140 km per hour and like that. Why? Because of the kinetic fraction will be less than the static fraction. Let's read.
Mr. كل ما الفورس
Let's go to the book to look over about the definition of kinetic fraction. Okay, I want someone, guys, please, to read the definition of kinetic fraction. Okay, anyone, please, guys. Okay, Amr. Yes, Amr. Read, please.
Kinetic fraction.
Yes.
Kinetic fraction, the force that opposes the movement of two surfaces that are in contact and are sliding over each other.
Aha, now look over, guys, the difference between kinetic fraction and static fraction. Now, kinetic fraction, they are contact and sliding over each other. Okay, they contact and sliding over each other. But in static fraction, at rest, the object not move. That is the difference between kinetic fraction and static fraction. Okay, guys? Suppose that, guys, we have two objects. Okay, the first object 100 kilogram, okay, and the other object 1000 kilogram. Okay, of course you can realize that when you push the object 100 kilogram, you will make a force less than about the object 1000 kilogram. Why? Because of the weight. The weight will exert in fraction. When we have more weight, we have more fraction, of course. Okay, and you should to use more applied force to let this object move. Okay, now we can say that the normal force Fn, okay, will exert in the fraction. More normal force, more fraction. Greater normal force, greater fraction. Okay, not just the normal force, guys, and also the service. The service will be different. When you push this object into carpet, not like you push the same object in on the ice, for example. Of course, the service will exert in the fraction. Now we have two things exerting on the fraction: normal force and the composition or qualities of the surface or the material of the surface. Okay, all of these things will exert on fraction. Normal force and the material of the surface will exert on fraction. Because that, guys, we have something called coefficient of fraction. Coefficient, okay, coefficient of fraction. Now, what is the coefficient of fraction? Coefficient of fraction, guys, it depends on the surface, depends on the composition and the qualities of the surface. The symbol of the coefficient of fraction will be like that, guys. It should be look like m, but it's Latin word called mu, like that, guys. That is the coefficient fraction symbol called mu. Okay, called mu. This is the letter of the fraction, coefficient of fraction. Okay, and this number will be different from the coefficient of fraction static and coefficient of fraction kinetic. Okay, if you look over in your book, you can find the schedule to explain for you some of the coefficient of some fractions for the surface, and depends on the surface. Look over in your book, you can find this schedule here. Okay, this schedule explain for you. Can you see that here? Now the still with the still. Okay, now the coefficient static fraction. Okay, it will be like that. Can you see that, guys? Every time kinetic coefficient fraction will be less than static. Kinetic less than.
Mr.
Static.
How can we?
Okay, guys. Now as you see here, now that is the coefficient of fraction for some surfaces. And as you see here, it will depend on the surface. Steel with steel, aluminum with steel, rubbery with concrete, and like that, guys. Okay, now every wood with wood, glass with glass, everyone has specific coefficient of fraction. And the static fraction, not like the kinetic fraction. You can realize that also the kinetic fraction will be less than static fraction. Kinetic fraction less than the static fraction every time. At the beginning, why? You can realize that when you push the object at rest, it's not like the object in motion. Okay, that is the beginning.
easier يعني.
Sorry?
easier.
Of course, easier to push
انا
the
لما اكون
object
اول
in
لما ازق
motion.
حاجه تقيله.
Yeah, to push the object in motion, not like to push the object at rest, of course. Okay, you can realize that. But in physics, why? Now, from the Newton's third law, okay, now every action we have opposite and equal reaction. Now, this object at rest, we have applied force action and a static fraction, that is reaction. Okay, this object is still at rest. Now, when the object starts to move, now we have applied force more than the fraction. and the net force, it will be like that. That is the net force. Suppose that this one 100 and this one 60, this net force will become 40. Okay, now in this case the kinetic fraction will become just 40, because the Newton's third law said that every action for the net force we have opposite and equal reaction. But here, if we apply it for 60, the static fraction is still 60 also. Okay, you can realize that here the kinetic fraction will be less than the static fraction. Guys, now how can we measure the coefficient of fraction? Okay, look over for the definition of the coefficient of fraction. I want someone, guys, please to read the coefficient of fraction meaning. Okay, let's take someone. Okay, Hamza, please. Hamza, can you read? What does it mean, guys? Now, it means that the ratio between the magnitude of fraction and the magnitude of the normal force. Okay, now that is the symbol of coefficient. Okay, now it equals the magnitude of fraction. We will make that F. It means fraction force. Okay, the ratio between fractional force and the normal force. That is the coefficient of fraction. Okay, that's the meaning of coefficient of fraction. And the scientists can count the coefficient of fraction by this way. When we know the fractional force and the normal force, we can measure the coefficient of fraction. And they made all of this schedule down to count all of the coefficient of two fraction between two surfaces. Okay, between two surfaces, and this coefficient of fraction, as I told you before, this depends on composition and the quality of the surface. Okay, guys, okay, guys, now look over the general formula for fraction. It will be like that. It will be easier to understand. Okay, F, it means fractional force. Mu, it means coefficient of fraction, and that is constant number, depends on the surface. And Fn here, that is the normal force. That is the normal force. Okay, now let's answer question quickly because we do not have more time. Okay, now the question here talking about the fraction, static fraction. Okay, very important to understand how can you get out the numbers and how can you get out the fractional force and the normal force and like that. Okay, now 24 kilogram crate. Now we have object has 24 kilogram, that is mass. Okay, at rest. Okay, in horizontal floor requires at 75 Newton horizontally force to set it in motion. It means what? It means that we have this object, okay, and this object at rest, and we try to make applied force in this object equals 75 Newton to let this object move, but it not move yet. It not move yet. Okay, and we have here mass for this object equals 24 kilogram. What he wants the static fraction between crate and floor. If you know that he will give you he wanted the coefficient of fraction. Sorry, guys, he wanted the coefficient of fraction of static fraction. Okay, now look over, guys. At the beginning, the formula is we can say that mu equaled F divided by Fn. Okay, divided by Fn. Okay, now here F it means a kinetic fraction or kinetic fraction or static fraction, anyone. And the mu here, it means coefficient of fraction, maybe static coefficient or kinetic coefficient. Okay, and the normal force mean the weight, both of them the same. If he give you weight, it means give you the normal force. If he give you just mass, what you will do? you will multiply 9.8 to find the weight, and the normal force will be the same, mg, or 24 times 9.8. Okay, now look over, guys. Here, that is the normal force. Now the normal force equal 24 times 9.8, and the static fraction equals the applied force. The applied force, now the static fraction equals 75. Very simple, very easy. Okay, now mu equals FF 75 divided by 24 times 9.8 times 9.8, it equals approximately 0.32 newtons. That is the mu. Okay, guys, here I have very important note, guys. I'm sorry. Now, mu, or the coefficient of fraction, has no unit. No unit. Do you know why? Because this one measured by Newton, and this one also measured by Newton. Newton cancelled with Newton. Now this no unit for mu, for the coefficient of fraction. Okay, guys, I have finished. I hope you understand, and I'm sorry if I'm talking very quickly. I will upload this session in the Classera.